Have you ever stared at a battery and wondered why one end is flat and the other has a little nub? It seems so simple, but this design is actually a brilliant piece of engineering that keeps our devices running safely and efficiently. Today, we're diving deep into the surprisingly complex world of battery design to uncover the secrets behind that flat end. Stick around, because by the end of this video, you'll never look at a battery the same way again. Let's start with the basics. The flat end of a standard cylindrical battery, like a AA or AAA, is the negative terminal, also known as the cathode. The end with the bump is the positive terminal, or the anode. This fundamental difference is the cornerstone of its design. Electricity flows from the positive terminal through your device and back to the negative terminal to complete a circuit. This distinct shape is a simple yet incredibly effective way to ensure you can't easily mess this up. Imagine trying to power your TV remote. The battery compartment has little diagrams showing you exactly which way they go. The springy coil almost always pushes against the flat negative end, while a flat contact point touches the positive nub. This physical guide makes it nearly impossible to install the batteries backward. Why is preventing reverse installation so important? Putting a battery in the wrong way can have some serious consequences. At best, your device simply won't turn on. But in some cases, you could damage the delicate electronics inside. Reversing the polarity can send the current flowing in the wrong direction, potentially frying circuits that are designed to handle electricity in only one way. In multi-battery devices, inserting just one battery backward can cause the other batteries to try and charge it, leading to overheating, leakage, and in rare cases, even a rupture. The flat end versus bump design is a first line of defense against these problems. It's an intuitive physical key that only fits one way. This user-friendly design has been so successful that it's become a global standard, ensuring that a battery you buy in one country will work perfectly in a device from another. The flat end also plays a crucial role inside the battery itself and in the broader electrical context. In many electronic circuits, the negative terminal serves as the common ground or reference point. Think of it as the 0-volt baseline against which all other voltages in the circuit are measured. The large, flat surface of the negative terminal provides a stable and reliable connection point for this ground plane within a device. This ensures a consistent and even flow of current, which is essential for the stable operation of sensitive electronics. A poor ground connection can lead to all sorts of bizarre issues, from signal noise to complete device failure. So, that simple flat surface actually ensuring the integrity of the entire electrical system it's powering. It's the anchor that keeps everything running smoothly. Beyond just user convenience and electrical principles, the shape of a battery is also heavily influenced by the manufacturing process. The cylindrical form with one flat end is incredibly efficient to produce on a massive scale. During assembly, the components of the battery, the anode, cathode, and electrolyte are layered and rolled into a tight cylinder, which is then sealed inside a metal can. The flat base provides a stable foundation for this automated process. Machines can easily grip, move, and process these uniform shapes without issue. Imagine if batteries were irregularly shaped. Automated assembly lines would become a logistical nightmare. The flat bottom allows batteries to stand upright on conveyor belts, making them easy to fill, seal, and label. This standardization streamlines production, reduces costs, and ultimately makes batteries more affordable for all of us. This design consistency extends across different battery sizes. Whether you're using a tiny AA for your remote, a larger C battery for a toy, or a chunky D battery for a big flashlight, you'll notice they all share the same fundamental design, a positive nub and a flat negative end. This universal language of battery design means you do and have to relearn how to install a battery every time you use a new device. It's an unspoken standard that simplifies our lives. Even when we move to different formats, like the rectangular 9-volt battery, you'll see a similar principle at play. Its two terminals are right next to each other, but they have different shapes, one male, one female, to ensure they can only be snapped into place one way. The core idea is always the same: make the connection obvious and prevent errors. Safety is another massive consideration that the flat end helps address. The shape of a battery helps minimize the risk of accidental short circuits. A short circuit happens when the positive and negative terminals are directly connected with a low-resistance conductor, like a piece of metal. This can cause the battery to rapidly discharge, generating a huge amount of heat. If you had two batteries with bumps on both ends, they could more easily make contact if they were loose in your pocket with some keys or coins, creating a dangerous short. The flat end, combined with the recessed ring around the positive terminal, creates a physical separation that makes this much less likely. The insulating wrapper that covers the side of the battery can also extend slightly over the edge of the flat base, further enhancing this protection. It's a subtle feature, but it adds a significant layer of safety. Finally, let's talk about the end of a battery's life. The flat end even plays a role in recycling. When you drop off your used batteries at a collection point, they eventually go to a sorting facility. Automated sorting systems often use mechanical guides and sensors to orient and separate different types of batteries. The consistent, flat shape allows machines to easily handle and align the batteries for proper identification and processing. This makes the recycling process more efficient, helping to recover valuable materials like zinc, manganese, and steel, while also ensuring that hazardous substances are disposed of safely. So, from its creation to its disposal, the humble flat end of a battery is working hard behind the scenes. So the next time you pop a fresh pair of batteries into a device, take a moment to appreciate that simple, flat surface. It's not just a random design choice. It's a carefully considered feature that ensures correct installation, protects your electronics, provides a stable ground connection, simplifies manufacturing, enhances safety, and even aids in recycling. It's a perfect example of how thoughtful, user-centric design can become so universal that we barely even notice it. It just works. Thank you so much for joining me on this deep dive into the world of batteries. If you enjoyed uncovering this everyday secret, make sure to hit that like button and subscribe for more videos where we unravel the hidden genius behind the objects we use every day. Let me know in the comments what other everyday items you've always been curious about. Thanks for watching, and I'll see you in the next one.